Priority scheduling algorithm. A priority is associated with each process and the CPU is allocated to the process with highest priority level. Here's an example of priority scheduling algorithm in a situation. We all know that all other car must give way to the ambulance. So ambulance is the first one. Next is the police car. And so on and so forth. Here's an example of priority scheduling algorithm. We have process P1 to P4. All have arrival time of 0. Each have burst time of 5, 4, 6, 3. And have priority level of 4, 5, 8, 3. Here's the solution we will get using the formulas of waiting time, response time, turnaround time, throughput, and CPU utilization. Please look to your heart's content. Now let's go to the preemptive scheme algorithms. SRTF or shortest remaining time first. Pre-prio or preemptive priority scheduling. And round robin. So let's start. Here's the first preemptive algorithm. Shortest remaining time first. SRTF algorithm, a preemptive version of SJF algorithm. And a new process arriving may have shorter next CPU burst than what is left of the current executing process. Here's an example of SRTF algorithm. As always, we have process P1 to P4. Each have arrival time of 0, 1, 2, 4 respectively. And have burst time of 10, 8, 6, 3. So now that we're on the preemptive scheme algorithms. A process that have shorter CPU burst is the priority in this algorithm. Even if the process arrive first. Look at the Gantt chart we made. Of course we know that P1 is the first because P1 arrive at times will get only one burst time in P1 because P2 will arrive and P2 have smaller CPU burst than P1. So now P1 only have 9 CPU burst remaining. Same with P2. We'll get 1 because P3 will arrive and it have smaller CPU. Now P2 have 7 CPU burst remaining. Next is P3, we will get 3 CPU burst because P4 will arrive and it have the smallest CPU burst. Now that we got all CPU burst of P4. Next is all the remains of P3, P2, and P1, since we're on preemptive scheduling algorithms now. The formula we get on waiting time is different from the non-preemptive scheduling algorithms. To get the last submission time, simply look in the Gantt chart the last first execute of the needed process. Preemptive priority scheduling. In short, pre-prio scheduling. This algorithm will preempt the CPU if the priority of the newly arrived process is higher than the current running process. In this example of pre-prio, we will use 5 processes for you to understand it the best. In this example we have process P1 up to P5. Each have arrival time of 0, 2, 3, 5, 6 have all same burst time which is 3. And priority level of 8, 5, 3, 2, 0. Here's the Gantt chart of pre-prio. As you can see, the pre-prio is most likely the same as the priority scheduling and non-preemptive scheme. You will base it on its priority level and most of all its arrival time. The solution we will get using the formulas is this. Basically, please look to your heart's content.
Created using Part2.